This is number 11 from the Work and Energy worksheet. It tells us that figure 1 shows a 1 kilogram object ready to start sliding downward on a frictionless track. Compute the velocity of the object at points B and C. In the diagram, it shows us at A, the box is at rest, and then it's going to go through this loop right here and then end up at C. So as it's going down the track, it's going to go upside down right here. So I'm just going to sketch the object there, and it will be moving. And then at C, it will also be moving. It tells us that the height at A is 15 meters, height at B is 10 meters, and height at C is 3 meters. So we want to make our base level where it would be most convenient, in this case, the ground. So labeling this base level. And the diagram's already been labeled with point A, point B, and point C. So what's different about this problem compared to the previous problems? Well, instead of just A and B, you have a third, A, B, and C. So we'll list the given and find, and then we'll make our energy bar charts. We know that speed at A is 0 meters per second since the block is at rest. We know that the height at A is 15 meters. We know that the height at B is 10 meters. And we know that the height at C is 3 meters. And what's it asking us to find? Speed at B and speed at C. And I'm sorry, we also do know that the mass is 1 kilogram. So I'm going to make the energy bar charts on the next, just so that we have room. We need 3 of them now. And label these EEL, EK, EG, EEL, EK, EG, EL, EK, and EG. Okay, so here's for A, here's for B, and here's the one for C. At A, it's not moving, there's no spring, but it is above the base level, so all of the energy at A is gravitational potential energy. And we want to show our dashes for EEL and EK to show that it's not there. At B, there's still no spring, it is moving, and it is above the base level, so now we're going to have kinetic energy and gravitational potential energy. And then at C, again, there's still no spring, but it is still moving and it is still above the base level. So we're going to have kinetic energy and gravitational potential energy. Again, what's important is that the number of boxes here equals the number of boxes here and also equals the number of boxes here. So in my case, I had 3, 3, and 3. First 3 steps. Energy at A equals energy at B. Now we have to extend that to equals energy at C. Kind of energy at A. EGA equals EKB plus EGB, which equals EKC plus EGC. Now the equations for each of these, EG is mg, so this is mg, height at A, your subscripts are really important here, equals 1/2 m v at B squared plus mg, height at B, which equals 1/2 m v at C squared plus mg, height at C. You'll notice that m appears in all 5 terms. This is not always the case, but here my m's can cancel out. We are left with g, height at A, equals 1/2 vb squared plus g, height at B, equals 1/2 vc squared plus g, height at C. This is optional. I don't like the fractions, so I always like to multiply everything by 2 to get rid of the 1/2. You don't have to. I'm going to, though. So now to get rid of the 1/2, multiply everything by 2. So this leaves us with 2g height at A equals VB squared plus 2g height at B equals VC squared plus 2g height at C. And the only thing you have to watch out for if you choose to get rid of this 1/2 in this step is that you are multiplying every single term by 2. So a lot of times I see you get rid of the 1/2, but you forget to bring the 2 everywhere else. Okay, so now we're left with two equalities. 2g height at A equals VB squared plus 2g height at B. VB squared plus 2g height at B equals VC squared plus 2g height at C. And also 2g height at A equals VC squared plus 2g height at C. And the one thing I really like about energy problems is once you get to this step, you have options in terms of what you want to set equal to what. And you're going to find in this case, it's not actually a system of equations. Even though we've got 2 unknowns, we've got 3 equations, so we've got more than enough. So let's start looking for the speed at B, because it's asking for the speed at B and the speed at C. If we're looking for the speed at B, we can set g height at A equal to VB squared plus g height at B. And see, I already made the mistake. This should be a 2 here. So now isolating VB squared, 2g height at A minus 2g height at B equals VB squared. Just to make the math a little easier, 2g height A minus height B equals VB squared. We have height at A, we have height at B, and g is a constant. So this gives us 2 times 9.8 meters per second squared times my height at A, 15 meters, minus my height at B, 10 meters, equals VB squared. So this is 5 times 2 times 9.8, 98 meters squared per second squared equals VB squared. And then taking the square root of that number, 9.89 keeps on going, meters per second equals VB. This is only 2 sig figs. So the speed at B at the top of that loop is approximately 9.9 meters per second. So this is essentially just looking at A to B. We didn't even have to worry about C for this part. Okay, now looking at finding the speed at C. Here's where your option really comes in. You know everything except for the speed at C. So you can set either A equal to C or set B equal to C. And I'm going to do it both ways just so that you know it works out both ways. It doesn't matter what way you do. I'm just going to show you how it does work out both ways. So let's start with setting A equal to C. 2g height at A equals VC squared plus 2g height at C. So doing the algebra, very similar to the last part. So this is 2g height A minus height C equaling VC squared. 2 times 9.8 meters per second squared times 15 meters minus 3 meters equals VC squared. So this is not as pretty. We have 12 times 2, so 24 times 9.8. This comes out to 235.2 meters squared per second squared equaling VC squared. Square root of that, 15.33 keeps on going. Meters per second is my speed at C. Again, only 2 sig figs. So VC approximately equal to 15 meters per second. Now I didn't have to solve for B first, I could have solved for C first. As you can see, I just solved for both of these independent of each other. But let's say now we wanted to solve for one and then go into the other, so using only B and C. Solve this the other way, using B equal to C. So this means you need either the speed at B or the speed at C to solve. So VB squared plus 2g height at B equals VC squared plus 2g height at C. And let's say I wanted to solve for VC, assuming I already had VB. VB squared plus 2g height at B minus 2g height at C equals VC squared. VB squared plus 2g height B minus height C equals VC squared. We already solved for VB, and if you'll recall, VB equaled 9.8, kept on going, meters per second, but we took that extra step and also wrote down that VB squared was 98 meters squared per second squared. And this was before when I solved for VB. So I know that VB squared is 98, so I'm just going to put that in right here. 98 meters squared per second squared plus 2 times 9.8 meters per second squared. Height at B, 10 meters minus 3 meters equals VC squared. So 98 plus 2 times 9.8 times 7. This is going to give us the same exact thing that we got before. 235.2 keeps on going, meters squared per second squared for VC squared. Square root of that, 15.33 keeps on going, meters per second for VC. So two ways still ended up with the same exact answer, that VC was approximately 15 meters per second. I don't think these are overly complicated in terms of solving. It's just arguably a little bit easier since you've got more things to set equal to. We will do plenty of practice tomorrow where we've got 3 different parts, so an A, B, and a C. Otherwise, if this felt good, then you should be great, and we'll keep on going with the energy.